Alright guys, last thing for 3.6 and then I'll get out of your hair. So what they do is for number 7, they have 3 lines here, and they ask us to find these 3 lines and tell which of these 3 lines match up with these 3 lines here. Okay, so kind of an interesting thing going on. But so whenever I do this, I try to look and see, well, what's one that kind of stands out and is different. And I see this has a 46 that is not the same as these two. That 46, remember, we got y hat equals a plus bx. The a is the initial value, or the y-intercept. So that's when when x is 0, that's the line will cross at whatever number a is. So if we look down at the bottom here, x is 0 right here, and so it's going to cross this first line at 46. It's going to cross at 46 up here, and that's right here. There's only one that goes at 46. So I know the first line A is this bottom one right here. So this is the A line right here. Now I have to choose between these two. They both cross at 50, and there they are right there. There's the 2 lines crossing at the point 50, right here at 0. Let's put a little. Alright, so right there, that's where they cross 0, and so these 2 lines cross the y-intercept at 0 right there. Now I got to look at this -6 and -4. There's a couple ways to think about this. The kind of shortcut way to look at it is, well, if you look at this line, -6, this line, this A line also has a -6. So they have the same slope. So these 2 lines would be parallel. Lines that have the same slope are parallel. And if I look here, here's A, and here's another parallel line. So this parallel line is going to be the one that has the same slope. So it looks like these two are going to, so these two have the same slope, A and B. So this one was A, this one's got to be B. That's A, this one has to be, this middle line has to be the B line right there. And then by default, this one's got to be C now because it's the last one left. Another way to think about this is this one, the slope is a -6, this is a -4. Remember, the slope is for every time we increase x by 1, we change the y value by whatever the slope is. For this line, I increase x by 1, so I go over 1, and I decrease by 6. For the other line, I increase by 1, and I only decrease by 4. So this number is going to get smaller faster, because every time I increase by 1, I take away $6. For this one, I increase by 1, I only take away $4. So this one, it doesn't get so small so fast. It doesn't. As we increase the x value, the y value is not getting so small so fast. It's kind of like if you were say buying some kind of product, and one product costs $6 and one costs $4. If you bought the $6 ones, you would lose money faster. If you bought 3 $6 ones, that would be a certain amount of money. If you bought 3 $4 ones, you wouldn't spend as much. So this line is kind of going down slower. And in terms of lines, if you like talking about lines and stuff, the one with the smaller slope is the line that is not as steep. The bigger the slope is, the steeper the line is, the kind of quicker it goes down. So this line is not as steep, so it would be the one with the smaller slope, the number that's smaller. So this is a 6, this is a 4. So the 4 would have the line that is not as steep. That's a little bit more technical, a little bit more looking at lines. If you're more of a college algebra kind of person, then that might make a little bit more sense. The other nice, but the way about kind of matching up the slopes kind of works out pretty good too. But so there we go, there's our ABC. And then the last question is, well, which one of these would you choose to be the line of best fit if you look at where all the dots are? I would choose B, because B goes in the middle of all the dots. A does pass through some of the dots. So A is pretty accurate when it comes to these two points. But remember, you want the line of best fit to go through the middle of all the data. Okay, so I think B would be the best one to be the line of best fit. Okay, all right, guys. So take that with you. Take a look at the take it home and everything, and make sure you work on all the stuff in between. And hopefully that worked out for us. All right, have a good time, guys.